Welcome to the DIY Honda Garage channel. DTC P0135 specifically refers to a problem in the air-fuel ratio, AF sensor, specifically the heater circuit of sensor 1, which is crucial in regulating the vehicle's emissions and optimizing engine performance. This sensor is found in the exhaust system and is responsible for measuring the oxygen content in the exhaust gases. The Powertrain Control Module, PCM, uses this information to adjust the air-fuel mixture for efficient combustion. When the AF sensor's heater does not function correctly, the PCM detects this malfunction during its monitoring process. The heater is vital during cold engine conditions, as it helps in bringing the sensor element up to the necessary operating temperature swiftly. If the heater doesn't meet specific current values set by the PCM, it triggers this diagnostic trouble code, leading to potential performance issues if unresolved. The error associated with DTC P0135 is indicative of a malfunction in the heater circuit of the air-fuel ratio, AF sensor, which has a crucial role in ensuring the sensor performs under cold conditions. The heater component is embedded within the sensor itself, located in the exhaust system. Its job is to reach operational temperatures quickly, allowing for accurate oxygen content detection in the exhaust gases, especially during cold starts. The PCM oversees the operation of this heater, and any deviations in the heater current indicate a fault, prompting the storage of this specific DTC. This issue may not only lead to increased emissions, but could also hamper the engine's overall efficiency due to incorrect air-fuel mixture adjustments. A thorough examination of the heater circuit is essential in diagnosing the exact nature of the malfunction. Several potential causes could lead to the triggering of DTC P0135, and each must be investigated methodically. One possible cause is an open circuit in the A-fuel sensor's AFHT, air-fuel heater terminal line, which can disrupt the heater's operation. Alternatively, a short circuit to ground within the same line would also hinder performance, leading to incorrect readings. The power supply line for the A-fuel sensor could also be open, cutting off necessary power. Furthermore, issues could stem from the PGM-FI programmed fuel injection sub-relay's power supply line also being compromised. The A-fuel sensor itself may be defective, and in rare cases, an internal failure of the PCM may be to blame. Diagnosing these possible causes requires careful inspection of wiring and components using appropriate diagnostic tools. With DTC P0135, several symptoms may be present in a vehicle experiencing this fault. The most notable indicator is the illumination of the check engine light, CEL, which alerts the driver that an issue has been detected. Alongside the CEL, poor fuel economy can be observed, as the engine's performance may be adversely affected by inaccurate air-fuel mixture adjustments caused by the malfunctioning sensor. Furthermore, vehicles with this DTC are at a higher risk of failing emissions tests, as proper functioning of the AF sensor is crucial for ensuring compliance with regulatory standards. Drivers may notice a decline in the overall responsiveness and efficiency of the vehicle as the engine struggles to maintain optimal performance levels. Addressing these symptoms promptly can prevent further degradation of engine performance. The first troubleshooting step for DTC P0135 involves starting the engine and holding the engine's speed at 3,000 revolutions per minute, RPM, without any load. This means that if the vehicle is equipped with a continuously variable transmission, CVT, it should be in the park or neutral position. If it has a manual transmission, MT, it should also be in neutral. This process is critical because it helps to ensure that the engine is operating under conditions suitable for testing the AF sensor's functionality. You should continue to hold the engine at this RPM until the radiator fan activates, indicating that the engine temperature is reaching a threshold where the AF sensor heater is tested effectively. This step is essential for confirming that the heater operates as intended when given the appropriate workload and environmental conditions. After establishing the initial operating conditions in the first troubleshooting step, the technician should proceed to verify the AFAT sensor's operation using the Honda Diagnostic System HDS tool. The HDS tool is specifically designed for Honda vehicles and will provide valuable diagnostic feedback regarding the AFAT sensor's performance. In this step, it is crucial to monitor the heater's performance and ensure it is drawing the appropriate current specified by the manufacturer. An analysis of the readings captured by the HDS tool will help identify whether the heater is functioning within expected parameters. If the heater is detected to be malfunctioning, or if readings are inconsistent, further investigation may be required, potentially leading to the repair or replacement of the sensor or associated circuits. Once all necessary repairs or replacements have been made in response to the findings from the previous troubleshooting steps, a final verification process is essential. Begin this process by using a scan tool to clear any diagnostic trouble codes, DTCs, that were logged in the PCM memory. Following this, conduct a test drive to allow the vehicle to go through normal operating conditions, which should help verify that the repairs were successful. During this test drive, it's imperative to monitor the engine's performance to ensure no symptoms of the previous malfunction return. After the test drive, it is also important to check for any recurring DTCs, specifically DTC P0135, to confirm that the issue has been effectively addressed. This process not only verifies the repairs, but helps guarantee the long-term reliability of the vehicle's operation. Preventive maintenance is crucial in ensuring that issues like DTC P0135 do not arise frequently or unexpectedly. Conducting regular checks on the AF sensor and its associated circuits can help catch potential issues before they develop into significant malfunctions. Monitoring engine performance consistently allows for early detection of inefficiencies that might correlate with sensor problems. Additionally, running routine diagnostic scans can help identify any developing faults within the system before they activate a diagnostic trouble code. Staying proactive with maintenance will not only ensure proper vehicle operation, but can also extend the lifespan of the emissions control system components, providing cleaner performance for the environment. In conclusion, addressing DTC P0135 is vital for maintaining optimal performance in the Honda Accord. The AF sensor plays a critical role in appropriate engine function and emissions control, and any malfunction in its heater circuit can lead to significant problems if left unchecked. Diagnosing the issue through the Honda Diagnostic System, HDS, is key to understanding the underlying causes and facilitating proper repairs. Moreover, the importance of preventive measures cannot be overstated. Regularly checking the sensor and employing routine diagnostics can prevent this issue from arising. By following these guidelines and ensuring the AF sensor functions correctly, vehicle owners can enjoy improved efficiency and reduced emissions while supporting a cleaner environment. Please like and subscribe to the channel. See you next time.